After the channel geometry and the part have been created correctly, and after the surfaces and curves have been properly named, the next step in our exercise is to convert this part into a computational region. This is required so that STAR-CCM Plus can apply boundaries and boundary conditions to the geometry. To do this, right-click on your part, which in our case is channel, and look for the option Assign Parts to Regions. When you click on this option, a new window opens where you can configure the settings related to region creation. At the top of this window, you can see that the selected part is channel, meaning we are creating a region for this part. You can change the region name if you want. Here, I will name it Channel Region, which clearly indicates that this computational region belongs to the channel. When you have multiple parts or multiple regions, these options become especially useful. In the lower left section, the first option asks whether you want to create one region for all parts. In our case, this is not critical because we only have one part. Below that, the software asks how the boundaries should be created for this part. What we want here is to create one boundary for each part surface. Therefore, select the option Create a Boundary for each part surface and make sure it is enabled. Before clicking Apply, look at the Regions folder. As you can see, it currently has no subfolders. Once you click Apply, a new subfolder called Channel Region is created. This channel region represents the computational domain associated with our part. If you click on the small arrow next to Channel Region to expand it, you will see its subfolders. One of these is the Boundaries folder. Inside the Boundaries folder, you can see all the computational boundaries that have been created for this region. Since we defined 3 surfaces, inlet, outlet, and wall, STAR-CCM Plus automatically creates 3 corresponding boundaries for this region. In the next steps, we will examine how to configure these boundaries and how to generate the computational mesh for our simulation.